In this new part, we'll start to talk about the Krakatoa stuff we have to do to the particles, and we'll see how to manage these particles, how to use it, and how to try to have more particles and manage the entire workflow. So, to render with Krakatoa, we have the possibility to go inside the menu there and set Krakatoa as rendering engine. We have to say yes because it is switching to Krakatoa, and you see that there now we have the Krakatoa user interface. So let's get on the first particle system. So in particle flow, we go inside the user interface. We can set of the 4 particles and go to the first one. It will take a little bit to activate because it is calculating all the particles. And the first thing we have to do is to see that we can render directly with Krakatoa. But the first problem we have is that we have to create a lot of particles to obtain something that can be a really nice look in rendering. So, okay, it is active. We have 25,000 particles actually. If we go there in the viewport, you see that it is better than before. If we go to render, and we can do it using the bring Krakatoa to front, so we have the particle there. We can simply click on render. It is preparing the particles. It is updating and generating the particles. It needs to generate the particles just the first time because after the first time it doesn't need to simulate the particles. The rendering is done. You see that now the frame buffer has all the feature coming with Krakatoa. But you see that we have nothing visible there inside the viewport. We can see the alpha to understand how the particles are working, and we see all the particles. We have no particles rendering in the RGB because we have no lighting, and the other properties are not set for the particle. The particles are using the color we have inside the particle flow, but if we like to manage the color, we can override the color properties there, or we can do it directly inside the global render value. You see that we have color override, and then we can set the color we like to use for the particle. And it's not the main issue. The main issue is that we have no lighting, but that's just about the light. So if we set one light inside the viewport, we'll have the rendering. So let's go to set for the moment just, for example, an omni light in the middle of the scene. It takes a little bit because actually the scene is really heavy because we have a lot of particles. And you saw that inside the rendering the particles are rendered, but it's not so nice. We have just points, and we have to remember that Krakatoa is a point renderer. But to obtain a really nice effect, we need a lot of particles. There are different ways to have a lot of particles. We can set, for example, more particles just using let's move inside the light for the moment. Let's go for the color. Maybe we can set to 1.5, and we'll have maybe a little bit of control over the lighting. So I am managing the space there for the fall off, and you see that I'm using the size about the particles there. So if we go to render now, you see that it is updating the particles. And what I was saying is that now we have the possibility to use more particles, just adding particles to particle flow. But you know that particle flow is really slow to calculate more particles because now we have to use, for example, some millions of particles to start having something really nice inside the viewport. Obviously, more particles you have, and the final result will be better. With Krakatoa, you can render a lot of millions particles, also billion particles, because it's really, really powerful. But you know that particle flow can be really, really slow to calculate something like that. So we have the possibility to use two really nice features coming with Krakatoa. The first one is the possibility to calculate the partition, and the second one is the PRT caching. So let's calculate the particles. You see that it is like the previous one, but this time if we go to see the RGB channel, we have the particles. We have yellow particles, and that's because we have the yellow color in the particles there. And other interesting stuff are that if you see the alpha is really, really heavy, we should have a lower density. But you know, if we go inside Krakatoa, so let's go to bring to front, we can decide to have a different color. For example, using the override, we can go to render, and you see now it is instantly rendered because we have the previous frame just rendered, so we have not to recalculate the particles. You see that we are obtaining a different coloring for the particles. And if you like to change the density, you have to go there inside the main control, and you see that there we have the final pass density. We can have a lower density, and with a lower density we can obtain a better result. Actually it is still heavy, but we can go lower and lower. So let's see, for example, with 0.1, and you see that particles are starting to be less visible, and the alpha channel is better than the previous one. But you know, we have to use a lot of particles to make it similar to a gas. So the first feature I was talking about is the let's save this version as KR render. So you know that this one is the one used to render the scene. So I was saying that to do something, you have to use the partition. And the partition is the possibility, we have the partition there. As you try to open the partitions, it is trying to find a deadline in installation. Deadline is another tool from ThinkBox software. It is a manager for the network rendering and network calculation. So you can use freely for two slates deadline, and in this case you can use deadline to calculate the particles over the network, and this would be really, really good and nice to have something like that, because the calculation for the partition can be slow, because you know particle flow is slow, so we have to manage to recalculate the particles. To understand how it works, the first thing we can do is to set Krakatoa to save particles. So now you see that we have the possibility inside save particles to say where to save the particles, and then there I can make a folder with test. You can decide the name, and you see that the file is saved in the PRT, the ThinkBox particle file, and this is a caching system where all the properties for the particles will be saved. I mean, it would be nice to have, for example, the age and the lifespan. You see that there in the particle channel to save to disk, we have all the information. So something that is nice is to have, for example, the age. And with these parameters later we can manage different properties for the particles just using the Magmaflow. So in this case, you have just to select, for example, age and put there, and you can do the same with the lifespan and put there. So we'll export all this channel for the particles. If you like, you can obviously save other properties too, but some properties obviously are for some other plugin like the file and viewer that are for film effects. We set the name, we set all the channel we like to export, then we have just to go inside the partition. It is trying again to connect to deadline. Okay, and now we can create the partition. To create the partition is really simple. We have to decide how many partitions. So every single partition has the same properties of this particle system. So in this case, if we have 50,000 particles, we'll have 10 particle system with 50,000 particles. So at the end, we'll have a total amount of 500,000 particles. And we have just to say how much particles, and then you can leave the default value. Here it is asking just which stuff needs to be created for the partition. So to create the other particles, it will use the random seeds. So it will control, for example, the speed or the position for the particles using different seeds. And with random position, random speed, etc., we'll have different particles doing the same things. When you decide that everything is right, you can click over Generate or Partitions Locally. In this case, it will calculate all 10 partitions, and it will save all the particles in this file. When you finish to export everything, we have the PRT cache, and we can load the PRT cache inside Krakatoa. So something that can be done is to export, for example, this one, and we can click over the generate all, and we can export it. So we have the PRT cache file, and to load the PRT cache file, we have to go inside the object, and we have to go inside particle system, inside Krakatoa, and we have PRT source, PRT loader, and something more related to PRT. Let's go to PRT loader, and we put a loader inside the viewport. That is creating the PRT. Okay, I have a workstation that is rendering more stuff in the background, so it is going a little bit slower than other times we use it for recording. Now it is asking for the particles. Let's go to use some particles. You have to record all particles if you like separately. So you see we have for the first one, the second one, the third one, and the fourth one. And I mean, I'm talking about the 4 particles inside PFlow. So let's load the first one. You see that we have files named with a name, and then we have partition 1 of 10 and the frame. So if you see, we have all the 10 partition for this particle. To load all partition, you have just to select the first file, set to open, and you see that now Krakatoa is asking to load the entire partition, because it is saying it seems that this file are part of 10 sequence partition. Do you like to load everything? And we say yes. And it is saying that it found all the partition there, and it is asking if we like to load everything. We say okay, add selected to partition. Now it is loading all the files inside the PRT loader. Let's wait. Okay, you see that it loaded the file. You see that we have a cloud of particles, and we can go to align this particle. So if you like, you see that we have the possibility to use the same orientation, the pivot point, as the other particles. So we have for sure, I think, to rotate this one by 90 degrees, and then it should work nice. Okay, let's go inside particle flow to set not visible the other particles. Okay, set to off. Obviously the PRT loader is really fast. We don't need to calculate the particles, so you see that this one is working. Okay, we have to rotate by 90 degrees. The PRT loader needs to be rotated by 180 degrees. Okay, so you see that we have the particles, everything is moving, and it's creating the particles there. I like to see if the position is right. We have just to move it a little bit. So from there, we have to go to 0. And let's go to move it also to 0 and 0. So we have the perfect position for the particles. So we can see again, you see that the particles are moving and we have no more weighting as the normal version done with a particle flow, because we are using a cache. If you like to have a cleaner rendering there inside the viewport, we can decide to go, let's open more there, and we can go to see the viewport. You see that actually it will use 100% particles inside the rendering, and actually it is using just 1% particles inside the viewport. So first of all, we can say to use a display as small points, so it is cleaner, and then we can start to use more particles. So you see that we are start with a lot of particles inside the viewport. Let's see how many particles we rendered, and you see that that's the particle system. So it's really huge. Let's see after some frames how it is working, and you did this. It's really amazing because we are moving a lot of particles. So back to a lower value, let's go for 1%. In this case, let's save. In this case, now we can go back inside Krakatoa, but we have to say to Krakatoa to go inside the rendering mode, so we'll not more save particles. So let's go there and say render particles. If we use the old previous version of the various parameters and we set to render, now you see that it's creating the particles, it is calculating the illumination, and it is working with 5 million particles. And it was really fast to calculate 5 million particles. And if we like, we can still manage the look there. We can, for example, use a lower exponent to have less density in the particles, and in this case we'll obtain something more gaseous, as you can see. And then we can, for example, manage the lighting, and we can say to use, for example, the inverse square lighting decay, and let's go for 3, for example. If we go to render, we'll have something different. You see that we have more lighting there, and then we have decay in the lighting. Let's try to render a more little, because now I'm using the scaling. So let's go for 700 pixel. Okay, you see that the look is similar to a gas. You can obviously change also the properties for the rendering, and we have various possibilities. One is, for example, let's go inside Krakatoa. One possibility is to use a different type of rendering, and the first thing is that you can use, for example, the voxel rendering, but it is not compatible 100% with the Omni light. So you see it is saying that it will use not the light we are calculating, but that's the rendering. You see that it's more gases as the effect. So we can go there, set to off this one, and try to illuminate the particles from out, just to see how it is working. Let's go for a target pivot just to see how it looks. And let's use a bigger hotspot fall off. Let's go to render. Okay, you see that it's creating the particles, and you see that the particles has a more gaseous effect, but the look is in general different from the other we were trying to obtain. So you need to decide what are you trying to create. So for example, we can go there and see how it looks when we stay the deeper rendering. You see that it's generating the particles. Okay, we have obviously the possibility to manage the look of the particles to have something different. So if you like to have something different, we can go there, inside Krakatoa, and there you see that we have the voxel size and the filter radius. So we can decide, for example, to have the voxel is the point that is rendered. We can say, for example, 3 to have a more little point. Okay, you see that the points are more little than before, and if we like, we can have, for example, a bigger radius for the filter. So that's the let's say something that will soft the point it is rendering. And you see that we have a softer point than before. So you can find the look you prefer just using this value, but we have the idea that we can control these properties also in rendering. So we can manage a faster rendering like the point render, and we can manage how it looks directly later inside the comp software, or we can use the other tool. It depends on the final look we are trying to achieve. Let's see at a lower frame. So you see that that's the look it is going to have. With the other light, let's say that this one is set to off. Let's go to light selection. We pick this light, and let's say that this one is more little, and we have, for example, 2, and then we go to have a copy. So using the shift key, let's make a copy, and this one has, for example, let's say a color like this one. Then we make another copy there, and this one has, for example, a green color, and let's go to have another copy there, and this one can be with, let's go for an orange color. And then we move a little bit the slide just to have different position. So this one will be moved there, and this one will be just a little bit there, and this one will be just a little bit in the middle. If we go to render, the look will be just a little bit different because we are using different light, and actually it is obviously off because we have all the light set to off. Let's go in the light lister and set to on all the light, and back to the render. If we go to render, it is generating the lighting coming with all the light sources we haven't seen, and that's the render. Let's go back to the previous frame where we have all the gas and the space. And you see that's the actual rendering. We can manage a little bit the various properties, and we can, for example, activate in the color there the absorption, and we can change the density to, to have something a little bit different. And to change it, we have just to go there and set this one, for example, let's go for 0.25, so a really low amount of density. So you see that we have a different look for the particles we have actually. And then we can manage, for example, again the lighting, and we can say that this one has a lower, you see, a lower space, and this will be something like 3. And let's go to manage the number 4, and also this one will have a more little space for the start and the end, and it will be higher the energy created by the light. And this one too will have a more little space. And then let's pick the first one, and this one too is picking a big area of the particles. So let's go to create something more little, and let's see the difference between the previous render. So we are creating areas with less lighting and more lighting. Okay, you see that we have some variation inside the light, and you see that we have higher energy in some area. Let's pick this one and set this one actually to off because it's still set to on, and we'll set it to a lower value to see just a little bit of lighting all around. In this case we'll have main light, you see, just in some area, and then we can set this one to on but with a low amount. Let's try with 0.5. Let's try to have something like that, or maybe like that, and let's try. We can have, I think, also an higher energy light for all the other light sources. So let's go in the light lister, and we can set this 1, 2, 4, 4, 4, and 4, and we can see the differences. You see that the look is really not bad. If we have the particles moving, as we see later, for example, let's go there. If we go to render, we'll see the particles in movement, and we can decide to, I think we can have also an higher value. You see that now obviously we start to see the lead particles, and this kind of effects can be managed inside the rendering. To remove this kind of effects, you need more and more particles. So you need to create more partition or more particles for every single partition, but it's not a problem because you see that Krakatoa is really fast to manage this kind of stuff. Let's go in the light lister again, and I like to go higher to, let's say, 6, 6, 6, and 6. Back to the view. Let's render. And you have to remember also that we are just working with the first particle pass. So you see that the lighting is really not so bad. When the text is generated and is still creating a little bit of text, we can see how it looks. That's the look, and again, it's really not bad. Back to save. So the other thing is that now we have to merge all the other passes. Let's select the PRT loader, this one. We can make a copy, and this one is the second one. Then we have to remove the particles we are using now, so we can select with the Shift key all the particles and click over remove. Then we have to say save, add files. Let's go in the second particle, select the first frame and say yes, and add selected partition. So you see that's the second particle. We can do the same with this one, but before we can see how it looks. We are still using the override for the coloring generated by Krakatoa. Obviously it is starting to be a little bit slower than before, but you see that we are starting to have a nicer look. Then let's copy this one. You know, we have to remove all the partition. Yes. Add files and add the third one. First frame, say yes, and add selected. You see that now we have this gaseous stuff also inside the text. We can see how it looks. And that's the actual look. You see that we are starting to see a lot of particles there about the lighting. So I think that the first light, I mean the white one there, can be less powerful. Let's see again the render. And you see that we have less white inside there. Obviously, if you have the possibility to have more particles, it will work better because you will see less point inside the rendering, but we'll tune up the compositing project to avoid an issue like that. So a lot of stuff will be done in compositing. Obviously, in your project, if you have the possibility to export more partitions with more particles, you need to tweak less inside the compositing, because you see actually we have a lot of points there and we have also a lot of lighting. So we have to tune up the lighting too at the end, but before I'd like to go to see the text when it is forming, and then I like to see also how it works when we have the fourth one. Then we have to move to the final look and we have to work on Magmaflow and the compositing project. So you see that it's really nice with some kind of really strange effect. Let's go back there. We can copy this one. For the fourth one, I'm using a lot of more particles. So let's select this partition, remove. But it is still rendering, so we can load. You see, I'm creating 20 partitions. So let's say load, but you see that we have just 12 partitions ready. You can load just this and say load. It takes just a little bit and then we have it. Let's render. And you see that we have more stuff than before. Let's go to tweak just this particle we just created. And to do something like that, I like to see at the beginning, because this one is formed step by step. So let's pick the number 3. And let's say that inside the viewport, we can set it to not renderable and not in viewport. Let's do the same for the other. Select everything and say viewport and render deactivated. And the same for the first one. So let's select everything and set to off. Then we can see with the fourth one what it's creating, and you see that this one is created step by step. So we can go to render. You see that we see this filaments. We can see it better there. We have Let's go a little bit there because we have no all partition already. Okay, and you see that the gaseous effects is really nice and really complex. If you like to have the motion blur, you can also add the motion blur. You have just to go inside Krakatoa and you have to say to enable the motion blur. You can use one or more segments. Let's try with 4 segments, for example, render. So it will generate 4 sampling for every single particles. More sampling will make the movement more soft and you will have less artifacts. So you see it is calculating more times the particles to obtain the final look, and it is really nice. Let's go back to some frames at the beginning, for example something like that. And let's see if we see something about these particles, but you know that particles are created later. Okay, you see, so we see not so much. So if you like, you can make start this particle before, so you will be able to see more gaseous effects also at the beginning. So for the moment, we can save and we can move to the next part. In the next part, we'll work on the final look, and we work on Magmaflow to manage the look of the particles and the coloring and the density also, and then we'll see how to prepare a nice looking compositing with Fusion.